Andrew, Alisa, and Lutz, welcome to the Passion for Sound YouTube channel and podcast. Probably, I think it's going to go to both places. We'll publish it at both. Now, Andrew, you and I were just talking offline. You and I have met via emails back and forth many times.
Yeah.
But do you want to introduce to me the other two people that are or two creatures?
This is the entirety of the Sparkos team. We have Alisa and our CEO Lutz, and we have some stuff about them on our website on the About Us page, and that's all very entertaining if someone's so inclined to go look at that. But he's our president, CEO. Thought it was appropriate to introduce him here.
Absolutely, yeah. We couldn't leave out the most important member of the team, could we? That's for sure.
Right.
And before we jump into some of the kind of technical stuff that we want to talk about today in terms of the op amps and the design of the Gemini and all that sort of stuff, how long Sparkos been going and how did it all begin?
Gosh, this is probably like our 10th year. I'd always wanted an audio company. Before Sparkos, I kind of designed this big power amp, as like a first product, but it's done. I'm sitting there looking at it. It's like, oh man, this thing's huge. It's going to be expensive. It's going to cost a lot of money to ship it anywhere. I was like, that's probably not a good thing to like start as a company with as a first product, But it occurred to me like, power amps are basically just really scaled down, or rather op amps are just a power amp way scaled down and vice versa. Power amps can be thought of as an op amp scaled way up. So I kind of looked around, I was like, well, yeah, these are discrete op amps are kind of a thing in audio. There was less people doing it 10 years ago than there are now. But, I was like, well, man, I can build one of these, a lot cheaper than I can build a giant power amp. At the time I could send them anywhere in the world for about $6, postage. So I was like, well, let me, come up with the design and try them out and put them on eBay and make a website and see what happens,
Nice.
know? And so I did all that and people started buying them and getting good reviews and feedback on them. And then I was like, well, I could probably do a voltage regulator too, so I did that product a year or two later. And then we did our big pro op amps. And then I was like, man, we got enough stuff now. Like I could probably start making my own gear, that uses our stuff inside. So that's, we come out with the Aries probably 4 years ago. And now more like 5, maybe.
Yeah, it's going back a while now that I think about it.
I was working on it 5 years ago. I don't know that it seemed like it got released in 2019, maybe. So
yeah, that could be about right. I'd have to go back and look at when I reviewed it because I think I reviewed it not that long after it came out.
Yeah, I remember because we unveiled it at Rocky Mountain Audio Fest, which is in October, and it was the last Rocky Mountain Audio Fest before COVID. So
there you go.
Was 2020. This had to have been Rocky Mountain Audio Fest 2019.
2019, okay.
So and we're that was the last show we did. We're going to do the Florida Audio Show this year and exhibit at it. So we're trying to get back into doing shows and exhibiting and things like that. And I just the other day finalized all the stuff with the head of the show to get us in. And
brilliant. So people can come and try it out, check it all out for themselves at next Rocky Mountain.
Well, it's the Florida Audio Show.
Oh, the Florida you said. You did say that.
Rocky Mountain Audio Fest doesn't exist anymore, unfortunately.
Oh, really? Okay.
Yeah, COVID kind of killed it, and that's really unfortunate. I hope someone will pick it back up, or maybe Marjorie that used to put on will pick it up again. But they tried to do it in 2020, canceled. They tried to do it again in 2021, canceled again, and she was just like, I'm done.
It was a tough time for shows, wasn't it, going through all the COVID stuff? So all the uncertainty and extra challenges of putting stuff on with the hygiene and social distancing, and it was a bit of a nightmare for a lot of those show operators. So hopefully it comes back because I know how much people enjoy being able to get in there and try the gear and meet the people and all that sort of stuff. So cross fingers.
Yeah, we're really excited about it. It'll be our first time that we have our own room.
Fantastic.
We're not exhibiting with someone else, so we're pretty excited.
Yeah.
And so you've got, just to make sure I'm not missing anything, you've now got the 3 different types of kind of chips, if you like. You've got your power controller, the regular op amps, the pro op amps. You've got the Sparkos Labs Aries headphone amplifier preamp, and then also the Gemini, I should say, headphone amp and preamp. Is that everything? Am I missing anything?
We have like a couple other obscure products that are targeted to really specific things that we don't necessarily sell a lot of. We have a little upgrade kit for like vintage Marantz and Sansui.
That's right. Yep.
receivers, right? The BA312 module, it's called. You know, our power supplies, voltage regulators, op amps, Aries and Gemini. That's pretty much the entirety of our products.
Great. Yeah. Which is a wonderful setup for anyone that's into headphones in particular. There's a wonderful range of stuff you can do there, whether it's rolling op amps in a different amp, whether it's playing with your Aries and or Gemini amps. There's lots of versatility there. That's exciting. And obviously you've got the collaboration with Geshelli Labs these days, where they're just made for your op amps to be rolled through easily if people want to play around with that as well. So there's lots of possibilities there for people to come and check out what you've got. That's great. Fantastic. When is the Florida audio show for people that are interested?
Mid-February. I want to say it's around the 18th or
it's the 16th.
16th through 18th.
16th?
It's like Friday, Saturday, Sunday.
Perfect. I'll see if I can track down a link. I'll pop a link in the description for, I don't know if I can do it for the podcast so much, but definitely if this goes on the YouTube channel, I'll pop a link in the description if people want to find out more and work out where to come and actually see you, meet you, and play with the gear. That's exciting.
Yeah, 100%.
Brilliant. And Alisa, what's your role in the company? How did you get roped into all this electronics madness?
It was, he needed help and it was right timing for all that. So just came on full time and been doing that for, I guess, 5 years. About 5 years now.
About the same time as the Aries was coming into fruition.
Yeah, maybe a
little before
that. Like, he's just like, I really need some help, and it was right timing for me. And here we are.
We're together. I don't know if that's known. I kind of wanted to present it like the X-Files, and we're Scully and Mulder. If you're familiar with that show?
Yep.
Yeah, and it's like everyone watching is like, well, are they together? Well, they should be, but they're not. I'm like, well, just kiss her already, Like, so I didn't want to come right out and be like,
we're destroyed all the tension for you.
We're married and all that.
Brought my old lady on,
so.
This made more sense.
I want to create more of a sense of mystery and allure.
Yeah, right.
No, I've just killed it for you. Sorry, Andrew. I think. Sorry, you go, Alisa.
Yeah, we do everything like out of our home, and so we're here all the time together and having fun.
Ain't sick of each other yet.
Yeah, that's a good sign. Very good sign.
We check in with each other like, are you sick of me yet? Like, we sit around and stare at each other all day. Like, no, it works for us.
We're good right now.
So
that's good. That's good. I think it's actually a really nice thing, because I know people really enjoy it, and I certainly really enjoy other partnerships in the hobby, like Gino and Sherry that we mentioned before from Geshelli Labs. It's kind of nice to see people, families getting involved in the hobby and putting out their own products and stuff. I'm not suggesting everyone should rush out and do it, but I think for those of you that have the ability to do it, I think it's fantastic. It brings a bit of personality and kind of heart to the product. I think is really lovely. So I think it adds something more so than anything else. And so with that in mind,
it's not always easy, but
I'll bet.
The reward is definitely there. So.
Yeah. Oh, that's good. That's good. So I reckon let's jump in and start talking about some of the specifics of the products that we want to talk about. And there's a bit to go through, because I've now reviewed the Aries, your individual op amps, and the Gemini, and we've never actually chatted about any of them before, other than emails that I've then used within the reviews.
Right.
So I think let's maybe start with the Gemini, because it's the most recent review, and I've got some viewers who've asked questions that they wanted to know more about. But then for those people that are watching or listening along, we do also want to talk about the op amps, some general technical stuff around amplification, and then also the collaboration with Geshelli at the end. We might touch on that as well. So let's kick off the Gemini. For those that are able to see, this is the Gemini here. For those that are listening to this on the podcast, you can check out the review on YouTube of the Gemini. So this is a hybrid solid state and tube amp combo headphone amp and preamp. And I've got a few questions to go through in no particular order. But the first question I guess I had, based on what I read on your website and then playing around with it, did you tune the Gemini specifically for the 6922 tube, or did it just happen that was the one that ended up really working well with it? Obviously, it works beautifully with 12AU7s, 6N1Ps, 6DJ8s, etc. But the 6922 seemed to be a really nice sweet spot. Was that deliberate or just the way it worked out?
Yeah, I mean, I kind of targeted the 6922 as the tube I wanted to use. When you talk about tuning it, really the only thing a guy has control over is kind of how much bias current you run and what you put the plate voltage at. Those are kind of the two parameters you have to play with. So they're pretty much optimized for that. But I also found like in the family of tubes, like they all kind of want the same thing, at least bias wise and voltage wise. They all have very similar noise characteristics. I kind of designed and optimized for 6922 and then kind of went back and made sure the other tube types would be suitable given how I'd biased it and how we're running the tube and so forth. But it was I guess you could say it probably was tuned for the 6922 specifically, although I would say that there wouldn't be a whole lot things I would do different necessarily if I was tuning it for something else.
For different, okay. Yeah, that's interesting to know. And speaking of the bias and the voltage and everything, one of the things I was really curious about was you've got the jumper switch in there where you can change the amount of bias that's going to the tube.
Right.
Can you explain a bit and probably dumbing it down into layman's terms as best you can? What's the bias doing in the tube, and how does changing that give you us more or less of the tube sound?
Okay, so like when in the manual, I kind of touched on these things. It's like, how much of a given tube sonic signature will be imparted into the sound kind of depends on how hard the tube is being asked to work. Okay, and what that really means is how much current the tube is swinging. Okay. So obviously, you turn up the volume, you're going to run the tube harder. It's going to impart more of its sound. But what the bias jumper does is it kind of defines for the tube what work even means. Say, for example, you bias at 4 milliamps and you're swinging back and forth 2, up one, down one sort of thing. You can think of that as like it's doing 50% work, right? When you increase the bias and you still swing this, say you double it to 8 and now you're still swinging 2. Now it's only working 25%, we'll say. So to the tube. And so that's what the bias does, is kind of defining what work means and what work as far as the tube is concerned is. So that's kind of the idea behind that. And that's also why I like it doesn't change the gain or perceived loudness when you're playing with that tube jumper, or the bias current jumper rather. But yet it will impart more or less of the tube sonic signature based on whether the tube's working harder or not so much.
Okay. And so is that then, just making sure I'm putting this together right, is that why the high bias setting gives us less tube character? Because
exactly.
It's going to that wider range and therefore the swing is smaller within that range. Am I understanding that right?
Totally. Yeah.
Cool.
That's totally how it's a little counterintuitive or backwards, maybe, that higher bias is less tube, but that's what you just described is exactly what's going on.
Cool. Okay, no, that really helps me understand it, and hopefully others listening and watching this as well. And when it comes to the tube character coming through, is that because there's more of the distortion characteristics of the tube coming through? Is that really what's going on? As it worked harder, we get more of the distortion characteristics?
Yeah, it's the harmonic content that the tubes. I mean, you can call it distortion. Like distortion tends to have term. Negative connotations associated with it. And some distortion's pleasing to the ear, right? I mean, it's whether it's even order distortion or odd order, right? Like solid state things are more known for odd order that's displeasing to the ear. They don't occur naturally in nature. Even order, on the other hand, is considered to be pleasing to the ear. That's the characteristics that tube have, is the even order harmonic. They tend to occur naturally in nature as well. Echoes off the walls, things that make up a total acoustical environment, I guess. Even order harmonics are prevalent in those things. So but yeah, the harder you drive the tube based on how much, where the volume's at or what gain you have or bias setting, will impart more or less of the harmonics from the tube. And that's basically what's defining its sound signature and sound character.
Brilliant. No, that really helps, because it was something I noticed a lot as I went through. I did that sort of separate tube rolling video, and it was really interesting that some tubes I really preferred their high bias approach, others the low bias. It was different from one tube to the next, how much of that sound I wanted in there. And maybe even not even just sort of from one type of tube to the next. So like on one or two or three different pairs, for instance, of say 6N1s, one pair I might have liked it in high bias, another pair in low bias, because each of those tubes was different within that model number as well. So the need to tweak it's quite interesting.
Yeah, I found that too. Like, when you get into different manufacturers of the same tube, like they don't all quite behave and bias at the same points and sound the
Mm,
same. Even like I've gone through several of the electro harmonics tubes now. And even those, like, they're I'm more of a solid state transistor type guy, and the specifications and of those are much more tightly controlled than tubes. Once in a while I'll reject a tube, right
okay.
out of the box for either the two tubes don't match well in gain, or some of them have kind of noise or microphonic issues.
Yeah.
Making vacuum tubes is kind of rapidly becoming a lost art. There's only a couple of places in the world that still make brand new tubes. What those guys used to do, back in the heyday of the vacuum tube and maybe the 30 or 40s, like a lot of that knowledge I feel like has been lost. Maybe that's why
That would
the NOS tubes and the new old stock tubes are quite popular.
Yeah, I was just going to say that would make sense as to why so often it's hard to find a new production tube that can match some of the old. Often we think that everything newer is better because of newer technologies, but it's interesting to hear you say that about the lost art in some ways.
Yeah, yeah. As a general rule, that holds, but yeah, not in every instance, I don't think. So
Mm.
yeah.
No, that's really interesting. Yeah. Actually, while we're on that topic, did you come across any specific tube brands or models that you felt were particularly strong? Obviously, you've chosen the Electro Harmonics
Yeah,
6922, but were there
what
others that stood out?
right. So the electro harmonics is a great tube, and the things I liked about it are that it was always readily available. I don't have
Hmm.
to worry about running out or not being able to get it, which when you're doing manufacturing and production, that's important, right?
Yeah.
Yeah, J&J make really good tubes.
Hmm.
I like those. I like the Telefunken 6922. I believe I got that from Tube Depot. I kind of
Hmm.
went out and bought several new old stock tubes to kind of try them out and play around, see what they were like. A tube I like that's kind of obscure is a thing called the 12BH7.
I've heard
Okay,
of
and this,
those. I don't think I've tried one though.
yeah, they're a little bit longer, like length of the glass
Hmm.
envelope. They were popular in kind of like older Macintosh amps and some of those things. Kind of, it's a
Actually.
back in the day too. It's not typically in the conversation when guys are talking about 12AX7 or 12AU or 6922. It's a little more obscure, but that's one I kind of like. Just it's a little unique. It's harmonic content is almost entirely second order.
Hmm.
There's very little third order in it. That's an interesting one to me that I like. So yeah,
Okay.
I can say as far as tubes I like the least in the Gemini, I'd have to go 12AX7 as
Okay.
my least. Now 12AU, 12AT, 12AY, those are all great. But the 12AX specifically probably wants a little bit higher plate voltage than I'm running it at in there.
Okay.
It tend
Yep.
to have too strong of a tubey sound characteristic to where it's
Okay.
kind of bloomy and
Bit too thick
um,
and
yeah. Now some guys may like that. I mean, I'm not trying to tell anybody they shouldn't try a 12AX7 in the Gemini, but my own personal preferences anyway. That was probably the one I like the least, I guess.
oh, it's good to know. Give people a bit of hunting to go and do. They can try
Yeah,
some of those out
yeah,
for themselves and see what they like. And I think that for me
totally.
was one of the fun things about the Gemini was the ability to roll through so many different tubes, and then as I talked about in the tube rolling video, to then be able to tweak it accordingly. I think is really really cool that we've got that opportunity. So that's a lot of fun.
Oh, I was gonna say that's kind of something that I realize about like our Aries headphone amp. It's like there isn't really much to play with on the inside. I think we're way more known for like our discrete op amps and like our core customers, I guess you could say. Like they're guys that like to play with stuff on the inside. And
Absolutely.
so I was like, man, I should do a product that caters specifically to that. That's how a lot of those things came to be and why I put those features into there. And I'm the
Yeah.
same way. Like in a lot of ways, I feel like I'm my own perfect customer, or like my demographic, or the things I'm into would be what other our customers are into, and things I would want to see would be what they would want to see in a
Hmm.
in a
Yep.
design. And so that's how a lot of those things came to be.
Yeah, and I think that makes, I think at least makes for better product. Is that if you believe in and care about the stuff you're doing, I think it's going to show at the other end, and the people that are like you, therefore, are going to resonate with it and really enjoy it. And that's certainly
Yeah,
what I
yeah.
see in the comments and the discussions. That's the thing that people that are into like you said, particularly your op amps, they are the people that want to get in there and tweak and play. And kind of be a bit curious about what if I do this, and how about if I combine this and this, and some of the stories I've heard about people doing crazy adapter modifications to fit your op amps into the Geshelli Labs DACs.
Some
And
of those pictures that come in, and it was like, how?
Yeah, I'm like, wow, like that's hardcore, dude. Like these wired extenders, the op amps flopping around on the end of some extender. And it's that is amazing to me. Like the lengths that some guys are willing to go through to use our devices and things that maybe they don't have the room for it and weren't intended to have something that big. And where there's a will, there's a way, man. And I've seen guys do crazy stuff to be able to make it happen. And I enjoy that, man. The hot, like, man, this guy's got a soldering iron out and everything. That's good stuff.
Yeah, gotten right into it. And on that note, one of the things that came up in the conversations about the Gemini, and apologies for those that are listening to this as a podcast, but with the Gemini, the tube, for those that are watching it, can see that the tube's quite low in the case, so you kind of can't easily remove it without taking the lid off. I guess two questions in one here. One of them would it have been possible? Is there a solution to actually have created that with a higher tube socket? And is there a reason you didn't do that? And then part two of that question is, some people have said, is there any issue in using like a tube saver, socket saver, I should say, to raise the height of the tube to make that easier?
A tube socket saver you can totally use that to elevate it up. I mean, to me, that's very similar to like a dip socket riser that guys use on our op amps to elevate those up for parts that are close by or whatever. Yeah, just be a little careful if you're pulling it out that the tube riser doesn't come loose as well. I've had guys like, well, why didn't you just make the case like shorter, And it's like, well, the height of the transformer inside drove the height of the case. That was the tallest pole in the tent. So it's like, well, it can't be any thinner than the transformer is high. But yeah, you can use socket savers or all that. Tube depot, or maybe parts connection, or some of those. So they're probably $2, something like that. Perfect. We didn't use them in production. That was just probably a cost thing more than anything. An extra step and an extra thing in there. And guys are somewhat apprehensive.
I was going to say, I think it also is a trade-off in the sense that the way it's designed, it fits really nicely into a smaller space. Like for me, I can put it in the racks that I've got on my desk. If it did have the tube sitting up too high, I wouldn't be able to do that without risking damaging the tube. So it's one of those that's going to work really well for some people as it is. Other people are going to want that tube sitting higher, so you're never going to win on both. But the good news is they can use a socket saver, which is great.
Right. Yeah, I wanted to kind of have it poke out just for ventilation. I mean, tubes get hot. I didn't want to be dumping all that heat back into the enclosure. So I was like, I want to kind of stick it out somewhat, but not too tall where you got to worry about something bumping it or, breaking it or bending the pins or whatever. I know a lot of designs have the tube fully exposed. So that's kind of how all those things, how it came to be like it is, I guess.
Yeah, no, that makes sense. Makes good sense. So we had the question about the preamp. Now, I didn't get around to testing the preamp properly for my review because I wanted to get the review out so fast. You were kind enough to email me and tell me that the preamp output is actually kind of like a reduced down version of the output from both the tube and the solid state stage. Can you talk us through the reasoning, benefits, pros, cons, etc. for that decision versus, for those that aren't familiar, the other option, as I understand it, would have been to go straight from the tube output to the preamp output and bypass the solid state stage?
Right. So the preamp outputs are basically just divided down, scaled down versions of what's going to come out the headphone amp. I kind of wanted them to be consistent and be the same. But even a better reason, like the overall architecture of the Gemini, you can think of it as two-stage, like tube front end, and then our 2590 op amp being the output stage. But the way it works, you can't really pull out in between the two and just bring that out. You can think of it like a two-stage amp, but it's really all one stage. And what's going on in between the two is a current-based signal. So your RCA out and your headphone amp out, those need to be a voltage signal. But the link in between the tube and the 2590 discrete op amp is a current-based link. Okay. So it's not really possible to bring that out and bring that to the outside world. And the way it works, like the tube is kind of a voltage to current converter, and then the 2590 Pro op amp is like a current back to voltage converter.
Okay.
And what goes on in between the two is just a current-based signal that wouldn't be suitable to bring out to the outside world and pass off as an
Yeah.
RCA out
Right.
sort of thing. So.
Is that how tubes normally work? Are tubes normally the voltage to current conversions, or is that just the way you've chosen to set it up?
No, it is. Transistors and all these things are very similar. They all take some kind of voltage input and convert. It varies the flow of current through the device. You could then just like use a simple resistor to convert that current flow back to a voltage. That voltage just gets dropped on the resistor. But yeah, most devices are that way. Like most tube designs, they'll have a resistor up in the plate circuit, and as the current flows, plate current changes, a voltage is developed across that plate resistor. And, now you have a voltage based signal that, they usually capacitively couple it out and go on to the next stage or whatever they're doing with it. But yeah, on the whole, like transistors, yeah, they all vary the current through the device, and then based on resistors and things you put around it, voltage may vary as well. But fundamentally, they're changing the current through the device.
Interesting. Okay. The reason I was curious about that is I've been playing with some different products in recent times that are sort of specifying the fact that they're using a current-based amplification circuit. And so that's where I was curious. I was thinking, so is that actually the same as stuff we've always had, which is tubes? And it sounds like maybe it is, and it's just different ways of handling it, of course.
These things are kind of very difficult to explain. Like just to explain the difference between a current-based signal and a voltage-based signal is kind of off in the weeds a little bit. But you're right. There are, certain op amps talk about they're a current feedback op amp, know, and internally they work a little different. There's a little bit different principles employed in them. The current feedback op amps tend to be very high speed, and that's what they're gaining by doing a current-based feedback as opposed to a voltage feedback, which most standard op amps, certainly the ones in audio, are voltage-based feedback designs.
As you say, it starts to get very technical in a hurry, doesn't it, when we get into that area. I know that I start finding I'm trying to piece all the parts together as we talk, and
even myself. Some of these concepts, it took me years to wrap my head around. I was one of these guys. I got into electronics as a little kid. I was tearing apart TV sets. So, I'm now like 40 something. Some of these things, like to really wrap your head around, it takes a while.
Yeah. That's a really nice start, though, just to start to understand I think the key thing taking away from that for me was the fact that the solid state and the tube stage have to be tightly connected. I think is a really interesting takeaway that, like you say, it's not as simple as saying, we'll just take that signal from there and pop it out to the RCA sockets. It's not actually even possible because it's not the right signal type.
Totally.
Yeah, that's really good to know. Cool. Thanks, Andrew. We had some questions pop up about the op amps, and that's probably coming from the Geshelli Labs conversations with the J2S and the A3 Pro. One of the things that came up, and you just mentioned sort of current-based feedback, so I'll pick up on that, even though this is probably a little bit different. One of the things I said in my review of the Gemini was that I often prefer a zero feedback design. So for those not familiar with feedback, the idea of feedback, as I understand it, and feel free to correct me, Andrew, is that essentially you're taking a copy of the signal and feeding it back on itself, or inverting it, feeding it back on itself to essentially cancel out noise is how I've always understood it. Any distortion that's been added being removed by the feedback. Firstly, is that correct?
Well, not noise so much, but, the distortion artifacts or whatever. Yes.
Yep.
So, the op amp kind of watches its own output to make sure that it closely resembles a mirror image copy of the input.
Yeah. Perfect.
Thing.
Yeah.
They tend to be a distortion reduction technique in electronics. It's got to be implemented carefully. Feedback can cause, oscillations, instability, as the feedback loop kind of chases its own tail, so to speak. But on the whole, feedback is a good thing. Our maybe I'm getting ahead of myself in the questions. Like we've gone through the questions a few times, so I feel like I know where this is going.
Yeah.
But so in the Gemini, there isn't really any feedback. Now, the Pro op amp has its own local feedback around it. All op amps require feedback, okay, because they have very high gain, and you need some way to control that. So all op amps have feedback, but the feedback is not the tube rather is not enclosed in the feedback loop. Like it is possible I could have took the output from the Pro and looped it all the way back around to the tube. But all that would have done would have been to kind of reduce the harmonic content that the tube was putting out. I mean, it's a harmonic reduction technique. And it's like, well, if we're putting a tube in there, we kind of want to hear the tube. If we have feedback around the tube, it's just going to sound solid state again. You're diminishing the feedback of the sonic impact of the tube.
Yep.
So in the Gemini, we opted to not have any global feedback that encompassed the tube. And that's why, and it's kind of a unique case. When you start talking about our op amps and stuff, we take the complete opposite approach. Like, no, we want as much feedback and as much loop gain out of this device that we can possibly get. And there's some techniques that we do in the discrete world that the chip guys can't do that enable us to do that. I think that, again, I may be getting ahead of myself. I think I saw that question on there.
Yeah, no, this is going right where I was heading for, which was A, what's the reason for preferring to use feedback, which I think you've just answered. But then B, the second part of that question that I'm really interested in is I've regularly noticed that the discrete designs, whether it's a fully discrete like layout on a circuit board or an op amp style, like a plug-in chip, when I say chip, like a discrete circuit like your op amps are, as opposed to an integrated chip, which is a little piece of silicon. What I often find is the silicon-based integrated chips, they've almost always produced kind of a flatter sound, less depth in the sound stage. And I've always wondered what's causing that between a discrete designed op amp like yours, the Burson op amps, the staccato op amps. There's a few around there that I've tried.
Right.
I consistently find that the soundstage from those discrete op amps is better than from the integrated chips. Is that going to come down to how they're handling that feedback and what you just mentioned about being able to do it a bit differently, or something else, or you don't know? What's the?
No. There's that's a great question. I think I'll answer it maybe in layman's terms, and then we can complicate it up however, as much as you feel that your audience and viewers can handle.
And me, for that matter.
Because we can go way deep in the weeds on this.
All right, let's see where we go.
The easiest way to describe it is like, we're different art. We're both artists that use a different medium. Okay, those chip guys, they're doing a 2-dimensional picture, watercolor on canvas, right? Like a guy like me in the discrete world, I'm more of a 3-dimensional sculptor. Okay. So we're both creating art, in this case, the op amp. It's just that we use different mediums to do it with, right? Like that's kind of the simple way to describe it. Now, to get a little more technical, first of all, they have to cram everything into a itty bitty chip, right? And one of the things to get high amounts of feedback and all this is something called how the op amp is compensated. Okay, and compensation involves a capacitor to perform the compensation. And what compensation is it keeps the thing from oscillating when the feedback loop is closed, and so it doesn't chase its tail.
Yeah, okay.
The capacitors that required for compensation, when you put it in a chip, it always winds up being kind of a crappy capacitor. It'll have what's called a voltage coefficient. So as the voltage across that capacitor changes, with the signal or whatever, the value of capacitance it has will change as well.
Okay.
That's what makes it kind of an inferior capacitor. And the capacitors inside chips, almost all of them have that characteristic. Okay. When you get to the discrete world, we can use a capacitor. They're called NP0 or C0G dielectric capacitors. Think of it like a film cap or ceramic cap. This is just a flavor of ceramic. Okay. But these NPO and C0G caps do not have a voltage coefficient. Now, the drawback in them is they tend to be physically large, so large that they couldn't be implemented in a chip, but still small enough, we can use them in a discrete op amp design. The other thing is like we use, what's called 2-pole compensation. So we actually have 2 capacitors to perform the compensation, whereas the chip guys, they can't fit that many capacitors, and certainly not as big of capacitors, capacitance-wise, as is needed for that. Yeah, this 2-pole compensation, as far as I know, even in the discrete world, we're the only ones really doing that. You mentioned some like Staccato and some of those guys. I don't know if they do or not. I haven't seen their circuits. It should be evident in measurements, like if they provided like an open loop gain plot or something. someone like me could look at them and tell if they use
Okay.
single pole or two pole or not. So some of the other reasons that discrete are better than IC, like ICs, you can't really run a whole lot of power through them. The transistors can't bias as hard or as deep into class A mode as maybe
Okay.
you'd like. It's all thermal reasons. But in a discrete design, things are more spread out. You don't really have those, it's different medium, right?
Yeah.
Like,
Yep.
it got different things available to us that like the chip guys got available to them. Now, one of the common things guys will point out to me is like, well, the chip guys can make all their transistors match really well because they're doing it at the silicon level and all that. We can actually do the same. Like if you look at like our discrete op amps, you'll notice a lot of little 6-pin black things with 3 pins on each side. Probably 5 or 6 of those little 6-pin, three little.
Yeah, they're sort of scattered around the outside edge now that I'm actually looking at
they're
it.
kind of around the outside edge.
Yep.
So that is actually 2 transistors encapsulated into that one little package. So they will match really well. They will be thermally coupled to each other really well. So we retain that advantage into the discrete world that is the IC guys have in the IC world about how they can really match transistors and couple them tightly thermally to each other. And you really only need a couple transistors to match at a time, like the input pair transistors want to be matched to each other. Current mirror transistors, the two want to be matched that form each half of the mirror. They don't necessarily have to match all transistors to themselves. It's usually just a couple, and that's the idea why we use those particular devices or those particular transistors in our designs, because there's actually 2 transistors in that package. And so we retain the advantage that the IC guys have with matching and things like that.
It's amazing. And we've probably only just scratched the absolute surface here, but hearing some of the thoughts and the considerations that have to go into a design like this, I think as a layman, you sometimes come in and look at it and go, yeah, it's a bunch of circuits on a board. What's different compared to anyone else's bunch of circuits on or components on a board? The amount of thought that can go into a design. And I know talking to Gino over at Geshelli, I remember him talking once about the fact that even where he placed components within the circuit, because there were 3 or 4 different ways he could have done it, he said even that changed how it sounded. So there's obviously a lot of time and effort and thought that goes into a design like your op amps or your full-sized amps, etc. as well, I'm guessing, yeah?
Oh, yeah. It's wild. I mean, think of just like a piece of wire. Everybody just thinks a piece of wire is a piece of wire, but God, it has resistance. It has inductance. If there's other wires next to it, it's going to have capacitive coupling to those. So yeah, just like how you route your wires or traces on a board or something, like, those things can matter greatly. I see the same thing. I mean, I've done board revisions where all I'm doing is moving some traces further apart to reduce the coupling between them. Or making a trace fatter to give it less resistance or something.
And it makes an audible difference.
Yeah. Well, I don't know about audible difference, but probably, but certainly measurable difference.
Yep.
Like if you measure crosstalk from right to left, to me, I don't really care if I can hear it or not. It's like I can improve that, and measurements will definitely tell me if I've improved it or not. Ideally, you want 0 crosstalk, and then it's just how much you kind of end up with and can you improve it. And certainly moving traces around and how your board's routed and the proximity of one part next to another, things like that can all impact it.
Wow, that's amazing. And I'm guessing it's one of those things where it all adds up too. So you might not be able to hear that change or that change individually, but the combination of all of them together will no doubt end up in something audible.
Yeah. And I definitely like I approach design, like I spend a lot of time in simulation, but that's a very sterile environment. 2 traces in your circuit simulator aren't going to crosstalk no matter what.
Yeah, good point.
You know what I'm saying? So I start there, and then when I build a prototype or something, like I don't listen to it for quite a while. Most of the things I'm doing at that point are taking measurements, things that are very objective. Like yes, I improved this. I can things like noise, right? Like noise is pretty much always bad. Anytime you can reduce noise, it's probably good. Never mind if you can hear it or a hiss in the background or whatever, and you can do all those things through measurement. So I get everything, ironed out. Crosstalk's another good example of that,
Yep.
I try and iron those things out as much as I can before I really sit down and listen. obviously I do that and do listen, but most of the things by that point, though, in my mind, the design's already 90% ironed
Yeah.
out.
And then it's those final listening tests just to make sure it all plays out in the real world like it should from a theoretical point of view. Yeah.
Totally.
Yeah. That
Yeah.
makes sense.
And I've already found resistor types that I like, that I kind of use. Thin film resistors are great. I try not to use coupling capacitors and whatnot, but when I have to for like compensation, like in the op amps, it's like, nope, NP0 capacitor. I don't really sit there and try different types of resistors or things like that and listen. And I just don't really design things that way. It's like I've already found kind of the best resistors that sound really good, and that's what I'm going to use. And any further agonizing over it, I just don't feel is necessary.
I think that's fair enough too, because I think there comes a point where there's different, but is it better? And so you go around and round and round in circles thinking what's the right resistor, but in the end there's no right one. It's just the one that you like. So
and I say this a lot. You ever seen the movie Joe Dirt? Yeah. It's got some of the best business advice I've ever heard comes out of that movie. You remember the guy with the fireworks and he only had snakes and sparklers?
I don't remember that
the
bit.
Indian?
Don't remember that bit.
Okay, well, anyway, this guy has a fireworks stand and all he sells is snakes and sparklers, which are super lame fireworks. And Joe's like, "Where's all the good stuff?" And he's like, "Well, snakes and sparklers are the only ones I like." And Joe Dirt says, "Well, it ain't about you and what you like. It's the consumer." And so I feel like in a lot of ways, like, yeah, I can, what maybe sounds good to me or what I think maybe doesn't to somebody. Like, it's the consumer. It doesn't matter so much what, I don't claim to have golden ears or anything. Yep. So I don't know. I think that's like a great piece of business advice. Like, it's not necessarily about you and what you like. It's about what consumers want and what they like,
No, that's a good point. But on the other hand, though, I think it seems like you've landed on a winner. So whatever you've chosen because you've liked it also seems to be what people like. Because I think from the bits and pieces I read, I feel like, and I've got no solid data behind this other than just the number of comments I read, it seems to me like your op amps are considered probably the best or one of the best in terms of the swappable op amps out there. So you're doing something right. That's for sure.
Yeah. And I was terrified, man. I'll never forget the first one I sold on eBay to some guy in Japan. I was like, oh, what's he going to think about them? Like, he's like, oh yeah, these are great, but like, I was kind of terrified what the world would think, or if they,
that'd be a big step.
I think it sounds good, but that doesn't mean that the world will, or, so, but yeah, I'd agree. It seems like when, we're definitely in that conversation when people start talking about discrete op amps and
100%.
Like that. And so
I realized that we kind of went on a good sidetrack, and one that I wanted to talk to you about. We kind of got off track on the feedback conversation though, because there was one key thing I wanted to ask you, which is that we were talking about zero feedback versus using feedback, and you were explaining how the op amps need that feedback circuit from a gain point of view. There's been multiple articles, documents I've read over time that some will say here's why feedback's good, others will say too much feedback is bad, and that there's a sweet spot somewhere. I guess I'm curious about it. Is it about the amount of feedback used? Is it about the way it's used? Is it just use as much as you can because it's always going to be better? What's your view on that?
I would think that if guys that would make claims like that, it just gives a sound characteristic that they maybe like if it's a tube circuit, right? I mean, tubes have a lot of harmonics that they generate. Feedback will reduce those back down. They may say like 20 dB worth of feedback's where you want to be, and it's just because they've achieved a sound signature that they like. From an engineering standpoint, like Bruno Putzneys, I don't know if I've mentioned him. He's a guy that, brilliant engineer, designed like the Hypex Purify Class D amps. Like, he really brought Class D into hi-fi audio. He's got papers on this, and he's like, as much feedback as you can have. Like, a perfect op amp has an infinite gain, or an infinite gain under the hood. And so if that's the case, they're always running infinite amount of feedback as well. And so, like, I advocate, like, as much feedback as you can get. You got to be a little careful with it, though, depending on how the rest of your circuit around it. Like I said, having a large amount of feedback that's still stable and not prone to instability. So it's possible, I guess, you can implement feedback in a manner that it's not very stable, and that could result in poor sound. and it's not really the feedback that's to blame. It's just kind of how it was implemented. And
Yeah, and I wonder, I've potentially incorrectly made the assumption there's been some designs that I've listened to where I feel like the life's been kind of sucked out of the music a bit by whatever's been done in the circuit. And I might have incorrectly made the assumption that it's the way they're doing feedback or the amount of feedback. I mean, a common culprit, and it's not always the case, but a common culprit is often the nested feedback designs like the THX AAA circuits. Topping have got their own nested feedback arrangement as well. And I reckon probably 60 to 70% of the time, it's definitely not all the time, but 60 to 70% of the time at least, I feel like when I hear those amplifiers, there's something missing from the music. It hasn't got soul, life, energy to it. And that's something like if I think about the Sparkos Aries, one of the things that I love about that amplifier is it's got this natural delivery to the music. It flows, it's dynamic, it's got energy when it's meant to have energy. And so, yeah, so I'm interested if it's a question of how they're doing feedback or if it's got nothing to do with feedback and it's something else. Is there a situation of feedback as you understand it that would result in that lack of life, or not really? Is it probably something else?
Yeah, that's a great question. What I can say about nested feedback loops, though, is that gets super complicated from an engineering standpoint. At least it can. There's a lot more things to consider, how it performs overall, if the loops interact or one causes a problem with another, sort of thing. I haven't really got into a nested feedback loop design, so it's hard to say. I mean, it could be a lot of things. I'd have to like look at their circuits,
Yeah. Yeah.
kind of see what they're really doing in there to really know. I suppose it's possible. Aries is kind of the same way. It's got an input stage op amp, volume control, output stage. The op amps have their own feedback because they require it. But I didn't, you could then try and take a global feedback around the whole thing. That would be like nesting feedback,
Okay. Yep.
I didn't feel like any of that was necessary. I didn't even entertain that in the design or explore it in the design. But certain circuits, depending on or amplifier architectures, depending on how they're implemented, maybe need that, or it makes sense to use a nested feedback design.
And that's interesting that you just mentioned about there's the local feedback, but then there's the global feedback, and maybe that's part of what it comes down to. And probably I won't drag you any further through the topic right now because I don't want to, those that don't want to talk about feedback, I don't want them to get lost in this. But
right.
maybe that's my next area of investigation, and maybe another conversation another day is, the differences in what it can do to the sound doing global versus local feedback circuits, and maybe it's the zero global feedback designs that I'm finding sound really good rather than those that actually take that loop all the way around. So maybe I'll investigate that.
And then you have to kind of debate and define what feedback actually is. I mean, some people would argue, and there's some amount of truth to it, that just sticking a resistor in the emitter of your transistor is a very tight local negative feedback loop.
Okay.
Current flows up, the resistor drops more voltage that pushes back against it. On some level, guys will say it's almost impossible to design any electronic circuit that doesn't have at least some level of feedback, even if it's just a emitter resistor on one of your transistors.
Okay. Yep. I guess, because you've got to be controlling the circuit somehow, don't you?
Yeah. So a lot of circuits kind of have these things that could be loosely interpreted as feedback, but in my mind, they're not. I wouldn't call that feedback. I mean, it technically is, but when you're talking about feedback, you're thinking about something that's in a global loop usually, or even within the op amp, it's around the entire op amp. It's just if you had multiple op amps strung together, if you got around the whole string of them or not. But and this is way off in the weeds, you certainly go way off in the weeds engineering wise on these things. But so it's somewhat important to define what feedback even is or looks like or means.
Yeah, that's a really good point. And I think that's where it gets tricky in the conversations in comments and forums and stuff like that is, us as lay people, we don't always know some of the intricacies. Like what you just said there has just opened my eyes to the fact that I'm talking about feedback. I don't even know which version of feedback I'm talking about a lot of the time because I never even knew it was a thing. Yeah. That's it. Yeah. So that's opened my eyes. I'll start paying more attention to the types of feedback and how it's being implemented and stuff before next time I say, I like a zero feedback design because maybe I don't. Maybe I like a zero global
Yeah,
feedback
yeah.
design. That's really interesting. So thanks,
And
and
your no feedback designs still have like emitter
some
resistors in
form
their
of feedback.
transistors or
Yeah,
a cathode resistor on their tube.
a little bit more nuance, as is always the case when you start to get into the details of these things. There's always more to it, isn't there?
Oh, totally. Yeah.
I had a viewer the other day say that I think he'd heard or read that single-ended amp designs maintain all the harmonic content of the sound, whereas balanced designs would cancel out the even order harmonics. Are you aware of that at
Yes,
all? Is there some truth in that?
totally. So yeah, single-ended versus did he use differential or
It didn't
what did
get.
he
He
just
didn't specify that in the comments. I don't think it was just a conversation around single-ended versus balanced. And my initial
okay,
thought was
balance.
there's probably more to it because there's
Balanced
multiple
is
ways to
what
do
he used.
balanced.
So and this again, we're getting a little bit into semantics and misnomers for things. Rather than balanced, I'll refer to it as a differential
Hmm.
input.
Yep.
Okay. Op amps are inherently all differential input devices. That's part of what characterizes them as an op amp. And yet, when you compare like a differential device to a single ended device or just amplifier stage, there are some differences. Now, you mentioned the cancellation of harmonics that differential devices have that single ended do not. And that is true. Then the question becomes, is that advantageous or not? You can look at it like, well, a differential design has less harmonics, less distortion, they're better, you know? Or if you want those harmonics, maybe a single-ended design is more appropriate.
Mm.
Another interesting difference between the two is that single-ended designs will also have 3 dB less noise than a differential
Yes.
design.
Yeah. Yep.
And there are applications for it. You know, several years ago, I looked at doing a phono amp product, and that phono amp product, the input stage was a single-ended discrete stage. And the main reason was the less noise that they tend to have. I didn't really care so much about preserving harmonic content. It was just like, I need as low a noise as I can. I mean, phono amps have massive gain, right?
Mm-hmm.
So any noise just gets gained up right
Yeah.
along with the signal. So you really want low noise and phono amp specifically more than any other application. You know, I did a single-ended design there. But you know, like I said, a differential input, or what he referred to as a balanced input design, op amps are all inherently differential input, balanced input, however you want to call it.
Okay.
So there isn't really like a way that a guy could make a single-ended discrete op amp that could replace differential input op amps.
Okay.
You know, there's just that isn't really a thing. But you know,
Yeah.
each topology or architecture has its advantages and disadvantages, and
Yep.
applications it's better suited to one or the other sort of thing.
Makes sense.
So,
And
yeah,
just for
that's a
those
great question.
that are hearing the differential term, just to make sure I'm understanding it too, we're talking about a circuit that's looking at both positive and negative at the same time, rather than just single. Or
if you think of it like that, though, everything is differential.
well, that's right, because everything's a wave of positive and negative voltage, isn't it?
Well, yeah, it's kind of like defined feedback. You know, even a single-ended design is you know, you can think of it as like having a ground, and then the signal swings above and below that ground.
So that would be the single-ended, yeah.
That would be single-ended, I would
Yep.
say. Differential, you got two signals that swing opposite of they're you know, it's not reference to a steady point like ground. It's
Yep.
reference to another signal that's equal and opposite.
Yep. That makes
Okay.
sense.
That kind of describes single-ended versus differential signals, but it doesn't maybe necessarily describe a single-ended versus differential amplifier architecture. Like the op amps have two input pins, you know, and the op amp only sees the difference between the two pins.
Mm-hmm.
You can
Mm-hmm.
tie one pin at ground and swing into the other, you know, or something like that. And really in single-ended relative to ground, you can think of as being differential. It's just that the other half of the differential is fixed and doesn't move. But I've heard this argument like, well, everything's differential basic. Like voltage only can exist between 2 points. It's kind of like distance in that regard, right? You got to have 2 points to define distance. Voltage is the same way. And then it's what are those 2 points, and does one point stay fixed and the other move, or do they both move? And so, yeah, that's kind of the differences there.
So it's kind of a how long's a piece of string question when it comes to this, really. Yeah.
Yeah, exactly. Yeah.
Okay. No, that's good to know. One of the things you and I were chatting about in the emails back and forth when we were planning this was just talking a little bit about the partnership with Geshelli Labs, because that's been I think really huge for a lot of us as enthusiasts in the
Oh,
hobby, being able to get our hands on the A3 Pro with your Pro op amps, being able to get our hands on the J2S with the smaller op amps in them, and potentially then, as we talked about before, people adapting the Pro op amps into them, etc. How did that collaboration come about? What led to it? Where did it all begin?
well, yeah, that collaboration has been great. Gino and Sherry are awesome people. They're the ones who run Geshelli. They're kind of husband-wife team like we are here. We met them in person last year at the Florida Audio Show. They're out of Florida, so that's like their local show. I'm sure you heard Gino and I sat up till 2 a.m, talking about electronics, audio, like.
Unfortunately, it was in Sherry's room and not mine.
So
Okay, you were lucky you got to sleep that night.
Yeah, she was asleep and Sherry was trying to.
I'll bet, yeah.
But here we are on the other side of the door, nerding out on. So how it came about, like, I didn't really know this. Like, so before it came about, Geshelli used to use little surface mount op amps in their designs. And those are easy. You can use pick and place assembly for them. If you're not trying to change an op amp, sure, surface mount little op amp would be what you'd pick. And then customers, I guess, their customers were like quietly buying op amps and adapters from us, sending them to Geshelli, and then Gino would be sitting out there in the lab, like installing these things, for people. And I didn't really know this was going on until one day I got an email from Michael Bruce, who has a YouTube channel. I think it's called The Short Bus or something. But he was like, you guys need to get together and figure this out. Like, you need to make something happen and figure out a way that it's easy to get your op amps into Geshelli DACs.
Mm-hmm.
And I was like, okay. So I was like, sure. I was like, Gino was copied on that email. I was like, yeah, I'm interested, and you want to talk about it, and sure. And we set up a call, and we're both like starstruck by each other. I'm like, oh my God, it's Geshelli, and they're like, oh wow, it's Sparko, and Gino was like, yeah, man. He's like, I'll relay out my boards to, where they don't need adapters, and we'll put a socket for the op amps, and then they can put your op amp or an IC, or, guys can play with that if they want, and I was like, yeah, that sounds great. And he's like, we can use your pros, in a headphone amp, which the pros have a lot higher output current capability. They can direct drive headphones, Originally, their headphone amp kind of had a op amp and then like a high current buffer to drive the headphones and supply the current for the headphones. I was like, you don't need that. Like, our Pro will do all that, So I kind of gave them a recommended circuit for driving headphones that I like. That it's basically the same that the Aries uses in its output stage, And I think that they call that the Arcal 3
That's it.
Pro headphone amp. Gosh, it's been great. They've been keeping us busy, man. They order a lot of op amps.
Okay, that's fantastic.
As time goes on, it just gets more and more. They're coming. I don't know if they've talked about it, or they're doing some interesting future projects that will have the ability to op amp roll.
We've talked. I just chatted to them just recently about the new DAC and the headphone amps, so the Zuffa and the Daisy we spoke about.
Okay, maybe it's a new DAC then.
Yeah, I don't think he's mentioned anything else. He alluded to the fact they do a balanced version of the Arcal 3 Pro, which would be the Aries 3 Pro. But that's all he's told me about at this stage. So yeah, if there's anything else going on, we're not allowed to talk about it yet, I don't think.
Yeah, right.
But yeah, definitely the Daisy DAC and the Zuffa were the next two that I know are coming. And I can't recall what he said. I think he said that there would be op amp swappability in the Daisy like there is in the J2S, for instance. That's exciting.
Yeah, I'm pretty sure there will be. There'll be like a couple options, I think.
Okay, fantastic. And that's right, yes, because he was talking about the fact that the Pro op amp is not a standard 8-pin connection, your Pro level op amp, is it?
Yeah, and it actually so a little history on the Pros, like that kind of big 1-inch square package, and it's only got 6 pins, 4 on one side, 2 on the other. That actually is a standard op amp package for like the studio and recording world. This package was invented probably in the 60s or 70s. It was invented before IC op amps were good. And so all the designs in that package are discrete designs. And in that world, they're a standard. And
Okay.
so when I designed the pros, I was actually targeting towards that world, the studio and recording world, and then, but we weren't really known in that industry, and we're still not really not. And guys were like, "Oh, I see this new op amp," but they're like, "You got to give us an adapter, man. Like, we want to put this in place of a dip 8, in my DAC or whatever." And so, we do have the adapters
Yep.
for them, that adapt their 6-pin pinout to a
To an
8-pin
8.
dip. And
Okay. Yep.
for duals, there's two of them stacked, to form like a dual op amp. And so guys are able to use those in those. But gosh, when they were first invented, I wasn't really even considering applications like that. It's more like,
Mm.
it goes back to Joe Dirt, it's like you got to give people what they want,
That's it. Yep.
and that's what people wanted. And I was like, well, I guess I'll invent an adapter for them.
Mm.
And that's how all that came to be.
Oh, that's good to know. I'd actually never realized. I've looked at your site that many times, but I guess I'd never gone hunting specifically for anything to do with the 2590, because I'd had the 2590s obviously operating in the Aries and then again in the A3 Pro, but I've never thought about rolling them. I've just enjoyed them where they've been.
Yeah.
So that's interesting. I'd never realized there was an adapter. So for others like me out there we go. We can actually get the 2590s. We can roll them, adapt them into, assuming space is available, adapt them into pretty much anything.
Yeah.
Brilliant.
Any dip application they're big. They're a lot bigger than a chip, and they're a lot bigger than our 3602. That's when guys start using those wired extenders and
sitting there flopping around there and
wrapping them in tape so they don't
Mhm.
short out to other things when they're,
Yep. Gets a bit scary in there, but hey, if it sounds good, go for it. Why not?
Yeah.
And so the other thing that obviously I want to know, and I'm sure others will as well, is there anything new in the pipeline from Sparkos yourselves?
Yeah, but nothing for sure. I mean, I just kind of finished the Gemini a few months ago.
Mm-hmm.
I've just, most of my time's just, production, building things, testing things.
Yep.
Yeah, it's the two of us.
Yeah. So it's not going to be not going to be a production cycle like some of those Chinese brands that there's a new version every other week.
But yeah, no,
we'd like to get to the level where we're throwing out new stuff, but that's takes time.
Yeah, we're actually hiring our nephew, who's going to start at the first of the year to help us with production and stuff, and that'll maybe free up my time to focus more on development. So yeah, I've thought of a few things. One thing with the Aries, I've learned that guys want remote control and they want 4-pin XLR out, and on our side, so those are kind of some functional changes that would maybe get made to it. From our end too, like the assembly and all that, it's painful for us. Like, I'd never designed an enclosure. I've always been a purely electronic guy. The Aries was my first attempt at an enclosure. And so the program I did it in, the machine shop I did it in, like, I'm having to powder coat the thing myself.
Oh, wow.
They give us like a raw piece of aluminum for the base plate with holes drilled in it. We then have to sit around and screw in all the standoffs.
Oh, geez, wow.
All that stuff's kind of, it's labor intensive and painful for us. And like the Gemini, I'm using a different company to manufacture those cases. And when we get them, they're already powder coated, already silk screened. All the standoffs are already in it. We throw our board in, screw it down, and put the cover on.
Perfect.
And we're done.
Yeah.
So I thought, maybe I'd redo the case with this new company for the enclosure and add some of the features guys wanted, remote, 4-pin XLR out. That's one possibility. And I've noticed there's things that I think the world needs that we could maybe provide. High voltage regulators for tube circuits. A lot of vacuum tube amplifiers, like, it's kind of hard to regulate high voltage, and as interesting as I think it would maybe not be the best thing it'd be kind of hard for consumers. Everyone, they'd have to figure out how to get it in there, and they're playing with high voltage, and there's definitely a shock hazard there, so that may be something that's a good idea, but in practice, maybe not so much. I thought about volume controls is another thing that I think the world needs a good volume control. The step attenuator in the Aries, I think, is very good. I've thought about maybe productizing that by itself, although it would be physically large, right? Because it uses relays and stuff. I thought to myself, like, well, maybe I could, instead of using relays, I could use analog switches, which is a little chip, kind of like a solid state relay, if you will, to do the switching. And then it could be much smaller, and I could make it like a standard volume control size, guys could just swap out the volume control. There'd be soldering
Interesting.
involved. The other caveat is they'd have to get power into this thing. It wouldn't be
Yeah.
completely
Okay.
passive. And then guys, how do they tap power, and what do they tap it from to get power into it? So these things would maybe be really good for advanced level hobbyists. They'd maybe be good for other manufacturers.
Yeah. Yeah.
But kind of like the average guy that just, it'd probably be hard stuff for them to figure out. And
Yeah.
I don't know if it'd be really good to have mass appeal, like the hardcore hobbyists, yes. Other manufacturers, yes. But beyond that, I'm not so sure if products like that would go over very well or not.
Yeah, I was going to say it's a shame that with a brand like Bottlehead, obviously coming to an end soon, because Dan from Bottlehead's decided to retire, and fair enough too. He's done amazing work out of Bottlehead.
Right.
But yeah, it's a shame with a company like that. Would have been such a great match for things like the high voltage regulator and also the volume control, being able to integrate that into a pre-designed DIY circuit so that people knew exactly where to take the power from and how to mount it, etc. So yeah, I don't know if there's other brands out there that are conducive to that. I know I've done 2-3 DIY kits now. Ella kit's one of them out of Japan. I'm guessing they're not probably the sort that are going to be, because everything's kind of quite tightly packed into a molded chassis, like a metal chassis. And then the other one's a little outfit in Australia that I don't think's looking to do big scale stuff either. So yeah, I reckon if there was a DIY manufacturer out there that was looking to kind of upscale their amplification options and versatility and be able to upgrade and do things differently, that'd be very cool. I don't know of any at this stage, but that'd be awesome.
Yeah, I've thought about making products like that too. Like I think our core expertise is just circuits and circuit boards, right? Like chassis work, metal work. Like I could if I didn't have to deal with that stuff, that would be fine with me. And so I thought maybe I should do little boards like, here's your RCA input board or your XLR input board. Here's a little gain stage board. Here's a volume control board. Kind of have the block approach, and then hobbyists and stuff could wire those up in whatever fashion to suit whatever needs they had. And so they're just getting a board and just wiring it up. They're not having to build the board from scratch necessarily, or even really solder. And then if they're trying to put it into a case or some sort, like they'd have to come up with that on their own. But a lot of guys, that's within their capability. They can drill holes and put standoffs. And
I was going to say, there's plenty of pre-made cases. You can go to your local electronics store and buy all sorts of sized plastic or metal cases. So that's potentially an option. That'd be very cool.
Yeah. I've thought about doing products like that too. That would just cater to the DIY crowd and things like that. So I don't know. I mean, I tend to do products or that I think will be fun. For me as a designer. And I don't know. I mean, when I think of something, Lachlan will be one of the first to know.
And if anything comes to mind, I'll flick an email for sure.
Yeah, and I kind of look around or kind of look at feasibility of some of these things. And sometimes it's like, okay, I'll abandon this. And other times like, I want to take this through. And, right now there's nothing that I've definitely said, like, this is what I'm going to do next. Just
still bubbling away in the brain and seeing what bubbles up.
Maybe in a few months or something, we'll maybe have something nailed down a little more firm of what we're going to do next. But as of right now, there's nothing with certainty I can say.
Planned. Cool. And for those that don't know, you can sign up to the newsletter for Sparkos on your website. Yeah, I think is an option there. So anyone that wants to keep in the loop, I remember seeing way back the first prototype when you shared a photo of the prototype of the Gemini way back now. And it was quite fun because there was that anticipation of, when's this going to come out and what's it going to sound like? And
I'm sorry it took so long.
No,
we talked about it for a long time.
We shelved it for about a year. We were like moving and stuff and had other things going on. I didn't have the time to put into the development on it. And then earlier this year I was like, okay, I need to pick that up and finish it. Our newsletter is a great way to stay on top of those things. I try not to be spammy about it. I think I only do one maybe every other month.
Yeah, it's not at all spammy.
So I mean, some websites you sign up for a newsletter and you'll get 3 emails a week or something. I didn't want to be that guy, you know. But yeah, that's a good way to stay abreast of that. That's
Perfect.
probably the best way, actually.
Cool. So yeah, if anyone wants to, I'll put a link obviously in the description on YouTube, and I'll try and put it in the podcast if there's a way for people to actually see it and access it and click on it. But otherwise, it's just sparkoslabs.com, I think, your website, isn't it? Is that right?
Yeah.
Mhm.
Yeah. So there you go, just sparkoslabs.com. People can jump in there and see the products and obviously sign up for the newsletter. Is there anything else, Andrew and Alisa, that you guys wanted to share, talk about, anything while we're here?
Not necessarily. I think you covered most everything.
Cool.
You sent me the kind of list of questions, and I was like, yeah, this seems like a pretty complete list, and not really anything outside of that. I mean, I love to go way off in the engineering weeds, if there was anything like that, but a lot of guys eyes glaze over,
Yeah.
or they don't care.
Why don't we plan to do another one? Because I deliberately didn't dive deeper into some of them, because there's some where my own personal interest, I'd love to go, well, what about this and why this and how this? But I thought I won't do that today, because A, I didn't want to blow out the time, and B, there's some people are going to have an appetite for that, some people aren't. So why don't we say that maybe in the new year, you and I will catch up. When I say you and I, us, all of us together, can catch up and go a bit deeper and get into that more technical topic, so that those that want that can dive into an episode, whether it's a video or a podcast, knowing that that's what's coming, and those that don't want that don't have to listen to us.
No, I'd be happy to talk about anything like that
Cool.
that you wanted to. Yeah,
that'd be brilliant. All right, excellent. Well, we might wrap up there for now, and we'll look forward to a full-on geek out nerd fest technical episode in the future. That sounds really good.
Maybe do
that'll
one.
Be great for him.
Yeah, do one with Gino.
He's only got me to talk to,
Oh, there you go. Yeah. So,
yeah. Get Gino in on it too.
That'd be great. Let's do that.
Yeah, he and I talked about some further collaborations with some stuff that I don't know if they'll ever happen. This was like just what we talked about at 2 a.m. at the show. But
okay,
I think he'd be happy to go into those weeds too. I mean, he's
awesome.
Brilliant
All right, let's plan for that in 2024. Well, thank you so much, Andrew, and Alisa, and Lutz, who's probably off doing something.
Did we get Lutz on camera yet?
We did get Lutz at the beginning. He got to say hello. So
I thought that was before we hit play, though.
No, we
got him back for the hello as well. So we've all met.
I know there's people that want to see that.
That's it. And now we've proved to the world that he is real. So the world knows. Yeah.
He's asleep on the floor right here.
Half his luck.
Good for a change.
Half his luck. Awesome. Well, thank you both. Have a great evening, and thanks for putting the time aside to share the knowledge and the insights about your products and the hobby in general. It was really, really valuable, and I appreciate it, and I'm sure the viewers will as well.
Yeah. Thank you, Lachlan.
Thank you.
I really appreciate the time we spent here and having us on. This is
pleasure.
Great.
It was wonderful.
All right.
Brilliant. Thanks both. I'll talk to you again soon.
All right. Have a good one. Take it easy.
Yeah. Bye.